Good morning, everybody. Welcome back to math. This is day 19, which we're in the 10th week. Means we only got 5.5 weeks left. All right, today we're going to look at chapter 4, section 2, and section 3 examples. I want to hold up section 4 because in section 4, that's going to be one of the most difficult ones that we have, the sections we have in the entire book, because that's when we look at polynomials of any size, any degree, and we start solving for them. And then afterwards, we look for rational functions and then inequalities. All right. So let's go ahead and go. Graph the polynomial function -2x to the fourth plus 3x cubed. Okay, when you're asked to graph it, I attached this stuff here. But if you remember from section 1, we really don't need this because when we sketch the graph, I'll show you why it's a lot easier using my way than all this stuff. But you still have to know how to use this. So the first thing you have to do are steps. Factor out the function. So step 1, we have h of x equals -2x to the fourth plus 3x cubed. So we factor it. Since it only has two terms and they both have x's, we could factor out an x, at least an x. There's nothing similar with the coefficients. You can always take out the smallest exponent of this x to the fourth, x to the third. I know I can take out 3 x's. So if I took out 3 x's from this first term, I only have 1 x left. And I took away 3 x's from the second term, I only have the coefficient, which is 3. Set the factors equal to 0 and solve. Then we have x cubed equals 0 and 2x plus 3 equals 0. Anything that has an x, I set equal to 0. To get rid of the cubed, I cube root both sides. So x, the cube root of 0 is 0. So x equals 0 is one of my solutions, x-intercepts. And the other one, since this one's negative, I'll go ahead and add 2x to both sides. And divide by 2. So x is equal to 3 over 2. That's my second x-intercept. Plot those 2 points on a graph. So this is step 3. This is step 2. This is step 3. Up here, 0. That's one of my dots. Right, and the other one is 3 and 3.5, which is 1 1/2, which is there. Now we're supposed to sketch the graph. I'll show you the way that this section is supposed to do it, but then we'll go back to the way I showed you last section. All right, so what we're looking at these are our external. These are also called critical values, because at those points, that's where the graph crosses the x-axis. So critical values, zero, solutions, x-intercepts, all the same thing. So what we have here, we have this interval, which goes from -infinity to 0. This interval, which goes from 0 to 3/2. And then this interval, which goes from 3/2 to positive infinity. So that's what this is looking for. We have to look for the intervals -infinity to 0, 0 to 3/2, and then from 3/2 to positive infinity. So we're going to look at now to see if the graph is above or below the x-axis in each of these intervals. So in this first interval, negative, pick a point that's not the end point. So I picked -1. And this middle interval, not 0, not 3/2, so I picked +1. And then this last interval, any point between 3/2 to infinity, I pick 2. Always pick the easy ones. Okay, so first thing we did, we factored them out, found the critical values, the x-intercepts. Then we take the intervals, pick a value inside those intervals, and now we're going to place them inside our function. And work it out. So step 4, plug the critical values into the function and solve. Because all we're looking for here, the value is really irrelevant, but we're going to need it to graph anyway. So that's the only real purpose of it. So what we're going to do here is when we plug this value in there, what we're going to do is see if it's positive or negative. If it's positive, it'll be above the x-axis. If it's negative, it'll be below the x-axis. There's the y-axis. So that's what we're looking for. We're seeing if the graph is above, below axis in each of these intervals. Since we have a factor here, let's go and use those. So when x is -1, we have -1 cubed, -2 times -1 plus 3. -1 cubed is -1. Negative is a positive. 2 plus 3. So this is -1 plus, or times 5 is -5. The sign is negative. So what this thing tells us is at -1, our dot will be at -5, which is below the x-axis. At 0, we know it's there, so we pick the value of 1, h of 1. Plug that in there, and let's see what we have. We have 1 cubed, -2 times 1 plus 3. So 1 cubed is 1. -2 plus 3 is 1. So the answer is 1. It's positive. Then it crosses at this one, or here's the next x-intercept. So we go to 2. We do the next calculation. 2 cubed, -2 times 2 plus 3. 2 cubed is 8. -2 times 2 is -4 plus 3. 8 times -1 is -8. It's negative. So this one goes all the way down here. 5. This is -5, 6, 7, 8. So at -2, we have -8. So what this says here is our graph will go something like this. The location of the graph is below the x-axis, above the x-axis, below the x-axis. That's what it's telling us. So all the points in this interval will be below the x-axis, all the points in this interval will be above, and all the points above and here are below the x-axis. That's what that chart tells us. But let's look at the way I showed it to y'all in last section. Do the same graph. So the same function from the last section. Okay. From here, remember, look at the leading term. A equals -2, which is less than 0. It's negative. And n, the degree, is 4. So it's even, which means both ends point the same direction. Both ends point the same direction. Since it's negative, they both point down. We know that. So our graph will look something like this. So we find the x-intercepts. We factor out the x cubed, which gives us -2x plus 3. Set those both equal to 0. Cube root this one. So x is equal to 0. Three equals 2x. I move that one over there and divide by 2. So x is equal to 3 over 2. Those are my only two x-intercepts. And I know from those endpoints, the graph goes down. We know that since there's no constant, the y-intercept is 0. We also know that the multiplicities are both odd, which means the graph crosses at those points. And it's a fourth order equation, so it's going to have a bend somewhere. Anyway, we don't know what that bend's going to be. So again, both methods work. It's just that if you remember the formulas, the rules we had last time, it'll make it much easier, much faster. All right, let's look at the next example. 2. From our notes, we have 4 terms. So the steps. Factor the function. Since we have 4 terms, at this stage of the game, we only know one method, the grouping method. So we put parentheses in the first 2, and the second, since the negative sign's inside there, we have to include it in the parentheses. Now we look at what do they have in common, factor out both parentheses. Inside the first parenthesis, they both have at least 2 x's. So I take out x squared. In this first term, if I took out 2 x's, I only have 1 x left. If I took away both x's there, I still have the coefficient, which is 1. In the second term, there's a negative, so I factor out the negative, and they both have a 4 in common. So if I factor out a -4, I go ahead and divide both of those by -4 to see what I have left. Negatives cancel. 8 divided by 4 is 2x. Negatives cancel, so we have plus 4 divided by 4 is 1. And that's exactly what we want to see. We only have 2 terms, and they both have the same numbers in the parentheses. When we do grouping, if you don't have that at this point, you're done. You can't use grouping. You have to use another method, which we'll do in section 4. Since we have 2 terms and they both have the 2x plus 1 in common, I factor that out. What goes in the second parenthesis are the coefficients. Since this is a cubic function, it's got a 3 up there, we have the 3 answers. Here's our first one. So now we set both of those equal to 0. So there's going to be our first answer, and this is going to be the next 2 answers. Now solve for x. Subtract by 1. Divide by 2. X equals -1/2. That's one of my solutions. Move the 4 over. X squared equals +4. Square root both sides. Whenever you square root a squared term, you have to put a plus or minus. Square root of 4 is 2. So here's our second and third answers. Plot them on a number line. So -1/2. Remember, this one is -2 and +2. Now what do? We look at the intervals. We look at that interval, that interval, that interval, and that interval. So beginning at negative infinity to -2, -2 to -1/2, from -1/2 to 2, and 2 to positive infinity. So we look at all four of those intervals. Yeah, it stops at the intersections. So negative infinity to the first x-intercept, x-intercept to x-intercept, x-intercept to x-intercept, x-intercept to infinity. So we're going from negative infinity to -2, -2 to -1/2, -1/2 to 2, and then from 2 to positive infinity. What we're going to do here, now we pick a number inside these intervals. So the first one I pick would be at -3. Inside this interval, I pick -1. It's an easy one. Inside this interval, I'll pick 0. So if you can use 0, use 0. It's much easiest. And then the last one, I'll use 3. Plug those values in the equation. And work it out. All right, so the first one we have 2 times -3 cubed plus -3 squared minus 8 times -3 minus 4. -3 times -3 times -3 is going to be -27. -3 times -3 is +9. Negative times negative is positive. 8 times 3 is 24. Minus 4. Positive times negative is negative. 2 times 27 is 54. It's 24. We can combine the negatives, which is -58, and the positives, which is +33. 58 is bigger, so it's negative. 58 minus 33 is -25. The sign is negative, so it's below the x-axis. That's and you do it for the other points also. So we know at -3, it'll be -25. The dot will be somewhere way down here. At -1, 2 times -1 to the third plus -1 squared minus 8, -1 minus 4. 2 times -1, -1 squared is 1. Negative is a +8 minus 4. -2 plus 1 plus 8 minus 4. -6 plus 9 is +3. Again, you should know how to do this already yourself. You don't have to bobble your bubble head and do that. So I need you to, at least to practice your math yourself. Because if you're just copying mine, then you need to know how to do it yourself. Especially when you have odd and even exponents with negative numbers. The rule is this: if you have an odd exponent, with a negative number, the answer is gonna be negative. If the number inside there is negative and it's an even exponent, it's gonna be positive. So you don't have to worry about the signs, just multiply the numbers. The third one is F0. So anything with an X disappears, so it's -4. That's the X-intercept. The Y-intercept, I mean, it's a constant. So this one's below. So at 0, the answer is 3. So we got a dot there. At 1, it's -4. So we can pop these points down there. So at 3, it's -25. At 1, at -1, it's +3. At 0, it's -4. And at 3, two times 3 cubed plus 3 squared minus 8 times 3 minus 4. 27 times 2 is 54 plus 9, 63 minus 28. +35. It's positive, so it's above the x-axis. All this stuff gives us a guide of where the dots are going to be. So at 3, it'll be up here. So our graph will look something like this. And that's all it tells us. Yes. On 0? If x is 0, anywhere there's an x disappears. 0, 0, 0. So all those disappear. All I have left is -4.
Oh, okay.
The y-intercept is when x is 0. Did you try to work it out? That's why you need pencil and paper and try it yourself. That question should have never come up. If you would have done it yourself, then you would have seen anything times 0 is 0. Then all you have left is -4, the constant. So again, whenever x is 0, you have the y-intercept. Now, with what we talked about last chapter, or last section, I should say. Look at the leading term. A is 2, so it's greater than 0. The degree is odd, so the ends point opposite directions. The left side goes down, the right side goes up. The x-intercepts are at -2, -1/2, and +2. We have to work that out. So we know the end behavior is on the left side, it goes down, and the right side, it goes up. The multiplicities are both odd, so they cross. This one crosses, this one crosses, this one crosses. So we sketch the graph. Again, if you review 4.1, you'll see what I'm talking about. It's went over all those steps last time. Let's look at example 3. In section 3 will be the last time I'll give you this. Because what we're going to do in section 4 is all I'm going to do is I'm going to give you this equation and you're going to factor it yourself. But again, I give you a polynomial. You're going to factor it out, which is done. Now you're going to set each one of those to 0, which is, that means your solutions are going to be -1, +2, +4. Because it's always the opposite of set it equal to 0. So we have our x-intercepts at -1, 2, and 4. We know the y-intercept is at -16. So what are my intervals? Very good. -infinity to -1. Very good. Excellent. Perfect. Right. Then we take a test value. So I'll go -2, 0, 3, and 5. Remember, the test value has to be a number inside that interval. It cannot be the endpoints. Then we plug those inside the function. If you want to, you could just plug them inside this. It'd be much easier. Instead of figuring out what -2 to the 4th is, or what 5 to the 4th is. It's much easier if you just plug them into these and just get smaller terms. For example, we have g of -2 is equal to -2 plus 1, -2 minus 2 squared, -2 minus 4. I'm just plugging in place of x and putting -2. -2 plus 1 is -1. -2 minus 2 is -4 squared. -2 minus 4 is -6. The only exponent I have here, -4 squared is +16. Negative times negative times positive is positive. 1 times 16 is 16. 16 times 6 is 96. So it's positive. That means it's above the x-axis. The point is going to be at -296. At 0, it'll be -16. It's negative it's below the x-axis. It's going to be at 0, -16, which is the y-intercept. Again, I'm taking this equation here and plugging in my value x. So x plus 1, or 3 plus 1, 3 minus 2, 3 minus 4. And I work those out. 3 plus 1 is 4. 3 minus 2 is 1 squared. 3 minus 4 is -1. 1 squared is 1. 4 times 1 is 4. Times -1 is -4. It's negative. So it's below the x-axis. It's at 3, -4. At 2, it's 96. At 3, it's -4. Bless you. At 5, 5 plus 1, 5 minus 2 squared, 5 minus 4, 6 minus 2 is 3 squared, 5 minus 4 is 1. 3 squared is 9. 6 times 9 is 54 times 1. It's positive. So it's above the x-axis. It's going to be at 554. So our graph, it's going through this point. It has to cross there. There's the y-intercept. It goes here, goes there, and back up. Again, with what we did last class, we could draw the same graph. 1 plus 1, so the degree is 4, which means they both point the same direction. A is 1, there's a positive 1 there, all the x's are positive. So it's greater than 0, so they both ends point up. We know we have an x-intercept at -1, at +2, and at +4. The end behavior, so we know out of the end 2 points, they have to go up. Our y-intercept, if we set x equal to 0, we have +1, -2 squared, -4. So -2 squared is 4. times -4 is -16. So we know we have a y-intercept somewhere down there. At -1, we know it crosses because it's an odd multiplicity. At 2, it bounces. And at 4, since it's 1, it crosses. So we could guesstimate what the graph's going to look like. Again, all that stuff comes from section 4.1. Section 4.1, we just did a rough sketch, and this one at least gives you some points. This method here gives you some points. Now we have some actual points to plot. All right, now the last example of this section deals with something called the intermediate value theorem. The intermediate value theorem says this. I'm going to read the whole thing, but basically what it says is this. If we have a function that's continuous, there's no break or anything in there, let's say it looks like this. And we have two numbers, A and B. Now, that's our domain. We're only looking at the graph at inside A and B. So at A, we have that point. It's at A, f of A. And at B, we have the point B, f of B. So far, so good. We have dots. If f of A and f of B have different signs. In other words, if that point there is positive and this point here is negative, then you have at least one x-intercept. That's what it tells you. What it says is there's a point in there, we call it C, where if you plug it in the function, it equals 0. That's what it tells us. It doesn't tell us how many or where it is. It just tells us it exists. Let's look at an example. Here's our first one. A is -4, B is -2. What this is asking you is use the intermediate value theorem, determine if it's possible to determine if there's at least one real zero between A and B. So intermediate value theorem says we have to find f of A and we have to find f of B. And if they have different signs, then there has 1 0, at least 1 0. So we have to, since A is -4 and B is -2, we plug those into the equation. -4 cubed plus -4 squared minus 6 times -4. And the other one's going to be -2 cubed plus -2 squared minus 6 times -2. What's -4 cubed? Is it going to be positive or negative? It'll be negative. 4 times 4 is 16. 16 times 4. 6 times 4 is 24. It's 64. Negative 4 squared is going to be positive. So 4 squared is 16. Negative and negative is positive. 6 times 4 is 24. (16) plus 24, they're both positive. It's 40. So since 64 is bigger, 64 minus 40 is 24. This one equals negative 24. Do the same thing with negative 2. Negative 2 cubed is negative. 2 times 2 is 4 times 2 is 8. Negative 2 squared is a positive 4. 6 negative is a positive. 6 times 2 is 12. 4 plus 12 is 16, minus 8 is a positive 8. So what can we conclude? Yeah, there's at least one x-intercept somewhere in there. Because that's negative and that's positive, we know there's a value between negative 4 and negative 2 where it equals 0. And we can figure out what that is too. But that's not what it's asking. Well, let's go ahead and find it. Let's go ahead and prove it. So let's find so our function is x cubed plus x squared minus 6x. Let's factor. Do they have anything in common? How many x's do they all have in common? They have one x. So we can take out one x from everybody. Because we're supposed to have 3 answers. So now let's go ahead and factor out the polynomial here. X and x. The sign's negative, so it's one's positive, one's negative. The bigger answer will get the negative. What times what is 6? When you subtract them, you get 1. Three and 2. Since the first sign is positive, the 3 gets the positive. And these are our 3 solutions. We set them all equal to 0. So find our x-intercepts. What the intermediate value theorem says that at least one number will be between negative 4 and negative 2. Yep, we have a negative 3. There's our x-intercept. All right, let's look at B. It's the same function, x cubed plus x squared minus 6x. A is negative 1, B is 3. So we try both, f of negative 1 and f of 3. Negative 1 cubed plus negative 1 squared, 6 times negative 1. 3 cubed plus 3 squared minus 6 times 3. Negative 1 cubed is going to be negative 1. Negative 1 squared is positive 1. Negative and negative is a positive 6. So the answer is positive 6. Positive 3 cubed is 27. 3 squared is 9. Negative and positive is negative. 6 times 3 is 18. 36 minus 18 is positive 18. We can't tell anything about that. It's inconclusive. Because they're both positive, they can have at least one x-intercept, but we don't know. The intermediate value theorem is not going to be useful there. It only works if they have different signs. And then you can do the last two yourself. Okay. So that does it for section 2. Let's look at section 3. Let me see. I'm going to give you some. Section 3, we're now going to deal with polynomial division, the remainder theorem, and factoring theorem. I should give you a heads up here first. Chapter 4, section 3, polydiv. This is what we're looking for. Remember, our entire purpose is we want to find the factors of the polynomial piece of x. Because once you find the factors, then you can set them equal to 0, and you can find the x-intercepts. We need to find the factors of px to find the x-intercepts. From last time, remember, a polynomial of degree n looks like this. This is the degree. Polynomial of degree n will have n factors. So again, the exponent tells us how many answers we're supposed to have, whether they're real, imaginary, or not. So the problem is we have to first find all these factors. So how do we find factors? There are a couple of ways. It was the simplest one we used by division. 18 divided by 2 is equal to what? 9. Because it gives us a real answer, no remainder, we know that 18 is made up of 2. So that's 18 can be made up of 2 times 9. These are the factors. Plus 0 as a remainder. So this is called, the top number is called the dividend. The bottom number is called the divisor. The answer is called the quotient. And whatever's left is called the remainder. That's horrible. So in this case, 18 is made up of 2 times 9 with no remainder. It works the same way with polynomials. Because if we factored out the top, what would we get? We get x and x. They're both the same signs. They're both plus. What times what is 6? When you add them, you get 5. 3 and 2. And the bottom is x plus 2. So if these cancel, we come up with our answer of x plus 3. No remainder. So that means if we take this equation divided by that, our answer should be x plus 3. Which means if that's true, there's no remainder. That means that this equation is made up of the factors of x plus 2 times x plus 3. So that's what it tells us. Same thing is here. Since 18 divided by 2 gives us 9.0, no decimal, no answer. So we know that 18 is made up of 2 times 9. Same thing here. X squared plus 5x plus 6 is made up of x plus 2, x plus 3. How do we find that now? We have 2 methods. Long division and synthetic division. Long division always works. No matter what kind of equations you have, it will always work. As long as the degree of the numerator is larger than the degree of the bottom. In other words, as long as it's a proper fraction. So let's look how we do long division. And synthetic division only works if the divisor, the bottom number, is of the form x plus or minus some number. If your bottom number is X plus or minus a number, we can use synthetic. And you'll see it's a lot faster. So let's do long division first. We have our equation here. So we have X plus 2 goes into X squared plus 5X plus 6. Now, always look at the leading terms. What times X gives me X squared? Just X. We need one more X. So now we take this and multiply it to both of those, and they go down here. So X times X is X squared. X times positive 2 is positive 2X. Change the signs and add straight down. Positive X plus 2 minus X plus 2 cancel out. 5X minus 2X is 3X, and bring everything else down. Repeat the process. Look at the leading terms. What times X gives me positive 3X? A positive 3. Positive 3 times X is a positive 3X. Positive times positive is a positive. 3 times 2 is 6. Change the signs and add. And your remainder is 0. So we see that this polynomial is made up of X plus 2 times X plus 3. So there we have it. This is the top number divided by X plus 2. It equals X plus 3. It's the same as long division we normally do. That's why we do this one. What we would do would be 2 goes into 18 9 times. 9 times 2 is 18. Change the sign and add. We have a 0 remainder. It's the same thing we used to do in the old days until calculators took over our brains. So let's look at synthetic division. Synthetic division only works if the denominator is of the form X plus or minus a number. And sure enough, it is. It's X plus 5X plus 6. The denominator is X plus 2. So it fits, so we can use the synthetic division. Only use the coefficients of the top number. That's one step. Solve the bottom equal to 0 of 4X. So whatever you have on the bottom, in this case, X plus 2 is equal to 0, so X equals negative 2. Because we're going to remember, in synthetic division, there are no letters. It's only numbers. So this is our denominator. It goes out to the side. And the synthetic division uses that symbol. It's the opposite of the long division. Now, inside here go the coefficients of X squared, of X, and the constant. So it's positive 1, positive 5, positive 6. You have to make sure that you start off with the highest exponent and each column is allocated. If you're missing one, then you have to put a 0 there. Start off by bringing down the first term. Now it's only a process of multiplication, addition. Multiplication, I multiply these two numbers and put it there. -2 times 1 is -2. Add straight down. 5 minus 2 is 3. Multiply these two now. -2 times 3. That goes there. So it's -6. Add straight down. And this is your remainder. What these numbers represent, since that's your remainder, this is your constant. This is your x value. So we have x and a +3. So that's what that turns out to be. Okay with that? Let's look at some examples now. Divide to determine whether x plus 1 and x minus 3 are factors of this. I know that the synthetic division is much faster, but you have to know how to use long division as well. So let's do it. Let's do this one both ways. So we see if we get the same answer. And then we could do synthetic division for this one. Once I'm sure you know how to use long division, then we'll use synthetic division from here on out. So we have x plus 1, x cubed, 2x squared, minus 5x minus 6. Again, look at leading terms. X times what gives me x cubed? I'm missing 2x's, so it's x squared. Multiply this to both of those. So x squared times x gives me x cubed. Positive times positive is positive. X squared times 1 is x squared. Change the signs and add. The first term always has to cancel. If it doesn't, you did something wrong. That's a checks and balance. If it doesn't cancel, you did something wrong. So 2x squared minus 1x squared is 1x squared. And bring everything else down. Repeat the process. What times x gives me x squared? What kind of x? Positive or negative? Has to be, because x squared is positive, it's got to be missing a positive x. The signs are important. So positive x times positive x is positive x squared. Positive times positive is positive. X times 1 is x. Change the signs and add. Negative 5x minus 1x is negative 6x. Bring down the last number. What times x gives me negative 6x? a -6. You notice how on the quotient part up here, the answer part, it always starts off with the highest exponent and it goes down. X squared, x to the first, no more x's. So that's keep on looking, make sure that happens. If that doesn't happen, again, something's wrong. So negative times positive is negative. 6 times x is 6x. Negative times positive is negative. 6 times 1 is 6. Change the signs and add. So what's your conclusion? What's your conclusion? Yep. That means that x plus 1 is a factor of the polynomial. And the polynomial p of x is that one. Okay, so let's do the same one. Since we know it's supposed to work, let's try synthetic division. We're going to do x plus 1 again for this. So how would you set it up? What's the first thing you got to do? Yeah, well, we have two things. We have to take the bottom number, the divisor, and set it equal to 0. So we have to first set that equal to 0 and solve for x. So we get x equals -1. Because that number will go out to the side here. And your polynomial coefficients will be here. Here's a coefficient of x cubed, x squared, x, and your constant. So it's going to be 1, 2, -5, -6. Then you bring down the first term and begin. Multiplication, addition. Multiplication, addition. So -1 times 1 equals -1. Add straight down. So 2 minus 1 is 1. Repeat the process. -1 times 1 equals -1. Add straight down. -5 minus 1 is -6. -1 times -6 is +6. Add straight down, we get 0. So because the remainder is 0, that means x plus 1 is a factor. What do we have left? How would you read this? Well, that's the constant. This is the x. That means this has to be x squared. So we have x squared plus x minus 6. It's a +1, +1, -6. We got the same thing up here. Now we only have to solve this for the other two answers. Since we know x plus 1 is a factor, now we have to just take this quotient part and factor that out, and we get the other two factors of the answer. And we just go from there. X, positive, negative, 3 and 2. So all our factors are x plus 1, x minus 2, x plus 3. That's what the whole thing is used for. How about x minus 3? Is that a factor? What about x minus 3? Which way you want to use? Synthetic or log division? Your choice. You want to do long division? Okay. So we have x minus 3 goes into x cubed plus 2x squared minus 5x minus 6. What times x gives me x cubed? X squared. X squared times x is x cubed. Positive times negative is negative. X squared times 3 is 3x squared. Change the signs and add. So 3 plus 2 is 5x squared. Bring down everything else. What times x gives me 5x squared? Just 5. Positive 5x. Positive is positive. 5 times 1 is 5. X times x is x squared. Positive times negative is negative. 5 times 3 is 15x. Change the signs and add. 15 minus 5 is 10x. What times x gives me 10x? A positive 10. You can't forget the signs. 10 times x is 10x. Positive times negative is negative. 10 times 3 is 30. Change the signs and add. The remainder is 24. So it's not a factor. All right, so if we use synthetic division for x minus 3, if we use synthetic division, what will you do first? Set that equal to 0. Solve for x. And only put the coefficients here. 1, 2, -5, -6. Bring down the first term. Multiply and add. 3 times 1 equals 3. Straight down. 2 plus 3 is 5. 3 times 5 is 15. Straight down. 15 minus 5 is 10. 3 times 10 is 30. 30 minus 6 is 24. So it's not a factor. And there's one more thing here. There's one more thing here. You notice how both of these remainders are in 24? What if we took this number? If we took the factor and set it equal to 0 and solve for it? What would happen if we took this and put it inside the function? Let's try it. Let's try P of 3. We got 3 cubed plus 2 times 3 squared, 5 times 3 minus 6. 3 times 3 is 9, times 3 is 27. 3 squared is 9. 5 times 3 is 15. 2 times 9 is 18. 27 plus 18 is 45. 15 minus 6, they're both negative, so it's 21. 45 minus 21 is 24. That works. So again, you have 3 methods now to see if something's a factor. Long division, synthetic division, or you can solve the factor and plug it in there. This will always give you the remainder. So it's whatever method you want to use to find factors. Oh, I gave you an example here too. Let's see here. Well, that's right. I'll go ahead and run through this one real quick. Use synthetic division. So what that really means is 2x cubed plus 7x squared minus 5. It means divided by x plus 3. Can we use synthetic division? Yeah, because the bottom is x plus a number, x plus or minus a number. So first step, take the denominator, set it equal to 0. Now put the coefficient side here. I start with the first one. This is x cubed, x squared, x, and constant. So the coefficient of x cubed is 2. X squared is 7. There is no x, so put a 0. And negative 5. Even if you were going to do long division, if you were going to do long division with this equation, you would have to put a 0x in there. You have to allocate each of those columns of each of the variables. Bring the first term down and begin. Negative 3 times 2 is negative 6. 7 minus 6 is 1. Negative 3 times 1 is negative 3. Add straight down. Negative 3 times negative 3 is positive 9. And this is your remainder. So it's not a factor. Given this function, find f of 10. That means anywhere you see an X, put a 10. Ten to the fifth, all that means is a 1 with 5 zeros. Ten to the fourth means a 1 with 4 zeros. Nope. 10 to the third is 1 with 3 zeros. 10 to the second is 1 with 2 zeros. And then 10 minus 8. Which times 2 is 200,000. Times 3 is 30,000. 100. It's much easier if you start from this, in this case, 10 minus 8 is 2. Ten minus 8 is 2. Negative 200 plus 2 is, since 200 is bigger, it's negative. 200 minus 2 is 198. Then we have a positive 1,000 minus 198. 1,000 is bigger, so it's positive. 1,000 minus 198. Ten minus 8 is 2. 9 minus 9 is 802. $30,000 is bigger than 802. So it's a minus. So 30,000 minus 802. Ten minus 2 is 8. 9 minus 0. 9 minus 8. Now subtract those. It's 1, 9, 10. 10 minus 8 is 2. 9 minus 9. 9 minus 1. 9 minus 9. 9 minus 2. There. You'll probably use a calculator anyway. But that's how you do it. That's all it tells you. So in other words, what this tells us, everybody knows how to read that. What this says is x is equal to 10. What if, because if we move the 10 over, we subtract the 10 from both sides, if we had this factor, and we took that whole polynomial and divided it by x minus 10, we would get that as a remainder. So if we took the f of x divided by x minus 10, we'd get something with a remainder of 170,802. Remember, whatever you have inside the parenthesis, that's the zero value. That's your x-intercept. I'm trying to hurry, get you guys out of here. Okay, determine whether 5 is a zero of this polynomial. All you have to do here is just plug it in there. Five to the fourth is 25 times 25. Is 625. 26 times 25. 630 or 650. 625 plus 25 is 650. Yes, it is a zero. So just plug it in there, work it out. Now, is I a zero? We can use synthetic division here. Actually, let's go back to this one here. Is it test whether 5 is a zero? We have x to the fourth, x to the third, x squared, x constant. If it asks you if a number is a zero, then you just use synthetic division. 5 times 5, this is 1. So 5 times 1 is 5. 5 0 is 5. 5 times 5 is 25. Minus 26 is -1. 5 times -1 is -5. Add it. 5 times -5 is -25. That way is a lot easier than the other way. So we can do the same thing here. Instead of plugging it in there, let's use long division. X cubed is 1. X squared is -3. Positive 1, -3. I times 1 is I. Add it straight down, so you have -3 plus I. I times -3 plus I times -3 is -3I. I times I is I squared, which becomes a -1. So it's -3I minus 1. Remember, I squared is -1. -3I minus 1 plus 1, the ones cancel, so we get -3I. I times -3I is -3I squared. That becomes a -1. So it's a positive 3. Yes, it is. Again, you have to remember everything we did in the past also, because we're going to talk about complex numbers. We're going to talk about rational equations, inequalities. All right, now this one is going to lead us into section 4. This one's going to lead us into section 4. All it's going to give us is the polynomial. It wants us to set it equal to 0, which is what we're doing to find the x-intercepts. So in other words, what's asking you just to do is factor that. Didn't give us anything else. So where do we begin? Let's begin with 1. See if that's a factor. See if that's a 0. So 1, -3, -6, -8. If that doesn't work, we'll try -1. Let's try the first one. 1 times 1 is 1. 1 minus 3 is -2. 1 times -2 is -2. -6 minus 2 is -8. 1 times -8 is -8, is 0. So there's your one of your zeros. That's one of your zeros because it made it equal to 0. Now all we have to do is look at this equation. Remember, that's the constant. This is the constant x squared. So it's x squared minus 2x minus 8. That's quadratic. The second sign's minus, so one's plus, one's negative. What times what is 4? When you subtract them, you get 2. 2 and 4. And the bigger number gets negative. So that's a 4 and that's a 2. Set them both equal to 0. Answer is -2. Those are your zeros. That's how we use synthetic division to solve polynomials. That does it up to section 3. Please practice these. Do your homework. Because we'll need to know these. You have to be very proficient on how to do synthetic division for the next part. Okay, everybody, sorry I kept you so long, but I want to go through all those examples first.